Okay, so want to welcome you all, faculty, staff, high school students, anybody that's out there listening in to our second seminar in our series. It's a Dwayne L. Ford lecture series, guest lecture series. So we want to welcome you to this that's taking place here at Andrews University Chemistry Department. And just a couple of things again that I went over with some at the beginning. We would like everyone to mute your sound. Then you could write your questions in the chat. For students in the class, Chem 210 students, write your name and write present next to your name. So we'll have an attendance record there to show that you were here and present, but we also want you to participate even more. We would like at least all our Chem 210 students to write at least one question, to write more than one. It doesn't mean that it will be answered because that might generate a lot of questions. And of course, anyone is welcome to ask questions as well. So today, we have a practice now of having students introduce our speakers. The student that would introduce our speaker today is Zoe Gentles. She is from East Lyme, Connecticut. She went to high school there. She's a chemistry major in our department. Her career goals include getting involved with epidemiology, becoming an epidemiologist, and chemistry is a great way to get to that career goal. Her hobbies include violin, baking. She's multi-talented, it sounds like here. Movies, poetry, and music. Right now, she's taking one of the heavier loads in chemistry in the sophomore year, doing OChem and Quant. So it's good to have Joey here. Is Joey here to introduce? You can unmute. Okay, Zoe, is she here?
I play fair, so I live all the way. There's a lot of material. Yes, but the nice thing.
Trying to find Zoe.
I don't see her.
Yeah, I know. I'm calling her right.
There she is. She's just getting up.
She's getting up. Okay. Okay. I'll stop calling her then.
At least I thought I saw her. Oh, she's yeah.
See her?
You better let her know.
Okay, Zoe, you on now, and to introduce our speaker.
All right.
Okay.
Okay. Let's start. Okay. Good evening, everybody. Today I have the great pleasure of introducing you guys to this evening's Dwayne L. Ford speaker, Dr. Sibrina N. Collins. Dr. Collins earned her Bachelor's of Science in Chemistry from Wayne State University in Detroit, Michigan. She continued her studies at the Ohio State University, where she completed her Master's of Science and Ph.D. in the field of inorganic chemistry under the direction of Professor Bruce Bursten. While studying at OSU, she gained training in photochemistry, where she studied photochemical reactive molecules using light. After completing her graduate studies at OSU, She completed her postdoctoral appointment at Louisiana State University in Baton Rouge, Louisiana. Her previous appointments include Claflin University, which is one of the 107 historically Black colleges and universities in the United States, the College of Wooster in Wooster, Ohio, and the University of Washington in Seattle, Washington. Dr. Collins has worked for the American Association of Advancement in Science in Washington, D.C. as a writer and editor, and as a director of education at the Charles H. Wright Museum of African American History in Detroit, Michigan. In August of 2018, she was awarded the DAP-CEP Real McCoy Award for her work in STEM education. Dr. Collins has also mentored 17 undergraduate chemistry students and published in peer-reviewed articles in scholarly journals such as Inorganic Chemistry, Acta Crystallographia, and Journal of Chemical Education, the Chemical Educator, and the Bulletin for the History of Chemistry. Dr. Collins is currently an executive director of the Marburg STEM Center at Lawrence Technologies University in Southfield, Michigan, where she's one of the founding executive directors. The Marburg STEM Center is home to the expansive initiatives of the LTU's campus. She's an inorganic chemist and STEM educator who integrates pop culture to teach historically underrepresented groups in STEM such as science. She uses movies such as blockbuster film Black Panther or Star Wars. Dr. Collins has written at least 3 critically acclaimed science education articles that use the fictional element of vibranium from Black Panther to teach students about the periodic table of elements. Now join me in a virtual applause as we welcome Dr. Sibrina N. Collins to our lecture today.
Thank you so much, Zoe, and I appreciate you saying the Ohio State University. Don't hate, do not hate me for that. So let me share my screen here. And let me change the display settings. Is that good? Okay, so I want to thank definitely Dr. Murray for this wonderful invitation to have a conversation about Black Panther, Frankenstein, pop culture chemistry, and humanities. And before I get into that conversation, I do want to let everyone know, although I'll be focusing on vibranium throughout this presentation, I really do investigate real elements on the periodic table. And what I'm showing here is a recent publication in the Chemical Educator, where we basically, my students and I, and I'm so proud of them, Kyle and Michael DeBoard, where they focused on developing metal-based therapeutics for treating lung cancer. And so what I'm showing here at the bottom of the screen are 5 metal complexes we focused on. My student, Kyle, was very successful growing X-ray quality crystals. You know, that's a hard thing to do. You got to pray to the crystal gods to get X-ray quality crystals. So that first copper compound actually has an octahedral center, and it does exhibit some modest anti-cancer behavior. So just some proof that I do focus on real elements. And so for those of you that are not familiar with Lawrence Technological University, basically, you know, I just want to make a couple of comments. So essentially, we know that STEM is a buzzword, right, today. It's a buzz acronym, I should say, but it's deeply embedded in the DNA of Lawrence Tech when it was established back in 1932, adjacent to Henry Ford's Model T factory. And so our graduates are in high demand across all 4 of the LTU's colleges. And if you are ever in Southeast Michigan and you want to visit Lawrence Tech or the Marburg STEM Center, you have an open invitation. And so our conversation today, so I'm going to tell you a little bit about what we do with the Marburg STEM Center, and then I'll go into some detailed discussions on pop culture and how we're using that to engage the next generation. So the STEM Center, you can essentially think of it as the clearinghouse or the umbrella, if you will, of all of the STEM activities on our campus. That includes our high school summer camps taught by our fabulous faculty. That includes Extreme Science Saturdays, also workshops taught by our faculty, and partnerships with the Detroit Public Schools and also Southfield Public Schools. And we have really 3 key focus areas, and those focus areas include basically the first priority, supporting current LTU faculty, students, and staff. The second is that public engagement piece, and finally, industry connections. And so our summer camps are really high yielding program. Nearly 50% of students that participate in those summer camps actually enroll here at Lawrence Tech for a degree. And so they're very important for enrollment. We offer nearly 30 different summer camps across all 4 of LTU's colleges, and these students can have a residential experience where they live in the dorms, or they can have a commuter experience. Where we have partnerships with various organizations. For example, the Engineering Society of Detroit, we partnered with them on their Girls in Engineering Academy for middle school girls. We had a virtual cohort of about 22 middle school girls, engaging them with engineering. And in addition to that, we also had a group of students, some students actually lead a discussion as part of Extreme Science Saturdays on drone technology. And now we also use pop culture to try to engage the next generation. So let me give you the backstory on how we actually came up with this paper. And what I can tell you is when I go to the movies or watch television, I cannot shut off my chemistry brain. And my sister actually encouraged me to see this movie back in February of 2018. I was not a fan of Marvel comics or any comic books really. And so I go to the movies with 2 of my younger cousins, and I'm enjoying the movie. And it occurs to me that this fictional African nation is thriving on the production and use of this element called vibranium. And as I watched the movie, I kept asking myself, if this element were real, where would it be in the periodic table? And I could not stop thinking about that question. That's what chemists do, right? We come up with these questions that we think are interesting and we want to answer them. So to make a long story short, I go home that night, start writing out what I thought this paper should look like because I was so excited about it and I couldn't stop thinking about the question. Sent an email to my colleague, Professor Lavetta Appleby, who teaches at the Department of Natural Sciences here at Lawrence Tech. And I said, hey, have you seen this movie? And can you ask this as a question on your next exam? And she did. And we found out immediately who the Marvel comic fans were in the department. And so we used some of their responses for the paper, and we submitted it for publication. Now, I was initially reluctant to submit it for publication because I wasn't sure if the editor would actually send it out for peer review, but they did. We got really great reviews, and it was published a little over 2 years ago. And so I'm not going to go through all of this here, but the question that was asked, the students had to determine what the elemental symbol should be for vibranium, propose an electron configuration, and oxidation state. And what we were really doing was simply leveraging the popularity of the movie to get the students to think seriously about the periodic table. That was the whole goal. And the majority of the students suggested that vibranium, if it were real, should be with the transition metals and the D block, or the lanthanides or the actinides. But there really isn't a right or wrong answer. The students just had to back up, support why they engage in evidence-based arguments as to where it should actually be in the periodic table. So I shared the paper on Twitter, and to my surprise, it kind of exploded on Twitter. I really wasn't sure what the response was going to be, and I just want to highlight a couple of responses. this first one, I'm all the way here for this, Wakanda Forever. This other one, Forget Infinity War, this is the best crossover ever. This response here really gets to the heart of what we were focusing on, really taking a holistic approach to thinking about the properties of the elements. And the truth is, this movie provides an opportunity to really talk about and celebrate the important contributions of women and people of color, right, in the STEM fields. And the character Shuri resonated with a lot of young people. We also had a faculty member in Brazil tweet about it, you know, so we were making some international, you know, connections. And what's really cool is when your PhD advisor gives you a shout out on Twitter and you haven't been in a lab to do anything. So I said, I did something good if my advisor is giving me a shout out on Twitter. But what was really, really interesting is that chemistry faculty on Twitter started sharing ideas for other concepts that I wasn't thinking about. So one professor said, you know, now you have me thinking about what's the half-life of vibranium, and, you know, thinking about those radioactive decay concepts, which we really don't get a chance to teach much, right, in general chemistry. Maybe in second semester general chemistry, you might be able to touch on that. Relativistic effects, when you think about the heavy atom, you know, dealing with the properties of heavy atoms, and also material science. So the point is, though, you can design a whole curriculum, you know, around using a fictional element to engage students. And so this other question from Dr. Tom Kupselman, who teaches at Spring Arbor University here in Michigan. He's a wonderful inorganic chemist. And so his question, wouldn't it be cool if vibranium had electrons in a 5G subshell? I thought that was a really, really interesting question. And I started digging into literature a little bit. And it turns out that, you know, back in about 50 years ago, you had theoretical chemists predicting the properties of these elements that weren't known, you know, at the time. And so the 5G subshell, and so now you're talking about filling the 8th period of the periodic table. That begins to fill around element 125. And so let's say, for the sake of argument, vibranium is element 125. We can do anything in the Marvel comic universe. Basically, using either one of those electron configurations, it can lose all 7 of these electrons, have a +7 oxidation state, anything is possible. But I think what's most interesting, though, is that you can ask students to determine what the quantum numbers for a 5G electron. The point is really to get people to think beyond what's already there on the periodic table. So this is just I thought this was just a really cool question. So we ended up being interviewed by the awesome Linda Wang in Chemical and Engineering News for the news script section. That's always a fun column to read. We were also interviewed by Wired, which has a much more broad readership. So that was pretty cool too. And then we got a shout out in Bloomberg Opinion. Now, we weren't interviewed for this piece. The author actually mentioned our work at the end of the article, because the article was focusing on the fact that Black Panther, didn't win the Best Picture award. But the author pointed out, here's a way that you have chemists trying to make connections to real science content to engage students. So that was pretty awesome. Now, we were also interviewed by Scholastic Science World, and that magazine is read by over 1 million kids, so middle school kids, high school kids. And what they did, their editorial team actually put together lesson plans aligned with the next generation science standards for students to classify vibranium using a bunch of worksheets. And so I'm sharing one of them. And so it occurred to us that we can use this brief article and these worksheets to develop workshops to engage middle school and high school students. And that's exactly what we did. And so what I'm showing here, so February 2019, we had 32 high school students on our campus working in teams. They read the article and they actually completed completed the worksheets, and they worked in teams to prepare these really creative posters for a gallery walk. And these students were so creative and artistic. So each team had to present, had a spokesperson to present where they thought this fictional element would actually exist. And it was a lot of fun. And one of the things that I know about young people, you always have young people that have this wonderful artistic ability, you know, so it's a wonderful way of bridging STEM and art and all of that in these kinds of workshops. So we did something similar for a group of middle school kids at Levy Middle School. And so basically I'm showing one of the posters that the students actually prepared, very creative as well. But one of the key differences that I noticed regarding doing this with middle school kids and high school kids is that high school students want to put all the knowledge they have on a poster. That's what they do. Middle school kids are only concerned with how pretty a poster looks. You know, and it was just fascinating to see the difference between these two groups, but they were really engaged with the content. So we also received an email from a high school teacher, a high school science teacher in Italy. And so basically she's using the paper to engage her students. And so she shared with us the blog that she actually created. And the thing is, you just never know how an idea can impact, you know, other individuals. And so we have definitely have a international type of audience as well. Now, one of the things that we did is, because that first paper really was a thought experiment, if you will, we actually published a second paper where students actually can create their own vibranium solutions in the lab. So getting some hands-on experience with transition metals. And so what I'm showing here are solutions of both copper and cobalt bound to the amino acid glycine. And this is why I love being an inorganic chemist, because the compounds that we make are just absolutely gorgeous, gorgeous, gorgeous colors. No shade to my organic chemistry brothers and sisters, but the only thing that you make, it's got to be yellow, white, or brown. There is no fun in that. So having said that, these are actually the cobalt compound actually resembles more the color that you observe in actually in the movie. So the students, these high school students, actually have the chance to basically work in teams and play the role of chemist, you know, in the lab. And we allowed them some time to utilize their cell phones to do some research about the applications of copper and cobalt as well. And that was a lot of fun. We ended up publishing it in the Chemical Educator last year as well. Now I'm also collaborating with Professor Lavetta Appleby again on a project, and also Dr. Daryl Boyd, who's a wonderful inorganic chemist. And Dr. Boyd is actually he was recognized as Chemical and Engineering News talented 12, I should say. And basically, we're working on creating a new chemistry storyline. So the Wakandanite series. So not only do you have vibranium, but you have elements curium and wakandium. And one of the things that we're doing is trying to utilize Slater's rules, right? And doing some applications there, calculating what the effective nuclear charge should be for the outer, that should be felt by the outer electron. So stay tuned for that. So again, just finding some other ways to apply these chemistry concepts. Now, last year, as you know, was the year of the periodic table. And what I would argue is that educators, chemists, we really do need to do a better job of utilizing the periodic table to engage young people. We have to come up with creative strategies to really capture their interest. But really, the question is, does inclusion of science fiction actually add any additional educational value or outcome. And so this was actually explored by Dr. Randy Yerrick in 2017. I want to say he's teaching at the University of Buffalo, I believe. And so basically, some key points of this paper regarding the value, he pointed out that, you know, science fiction is a way for educators to make cultural connections with their students in the classroom. And it also increases student interest, right? Because you're using student experiences. But keeping in mind that science majors are not the only ones that like to enjoy science fiction movies. Non-science majors also love science fiction films. So it's a way to really go, you know, have these curricular connections right across content. And so anytime you could have STEM faculty and humanities faculty working on a project to really engage students, amazing things can happen when you actually do that kind of work. And that's exactly what we did with this project, which is really about inclusive pedagogy, back in 2018, when, as you may recall, Mary Shelley's Frankenstein novel, it was a 200-year anniversary of that novel, and it's a brilliant, absolutely brilliant science fiction novel. And so basically we had we collaborated with a high school English teacher that teaches at the school district nearby. And she was teaching 3 sections of AP English with about 90 high school seniors. And one of their assignments focused on reading Frankenstein, and they also had to write an essay or composition focused on how Frankenstein's creature would be treated, you know, if the setting were today in society. And so basically those 90 high school seniors were on our campus for a faculty panel discussion and a seminar. And one of the faculty members, Dr. Eric Meyer, who teaches in biomedical engineering here at Lawrence Tech, started making comments about Marvel Studios' The Avengers movie and comparing it to Frankenstein, the novel. And so the students really started to connect with that. And so I followed Dr. Meyer's lead, and I asked the students if they thought that the relationship between Frankenstein and his creature in the novel somehow mirrored or aligned with the relationship that Eric Killmonger and their relationship between Black Panther and Eric Killmonger. And the students got really excited and said, yes, they were both abandoned by their communities and those kinds of things. So I had an aha moment, and we ended up putting together a manuscript for publication. And one of the reasons why I absolutely love to work across disciplines, I really believe in this no silos approach. And so my humanities colleagues actually carried out a text analysis of the student compositions on Frankenstein to identify various emotion tones in the composition. And one of the things that they noted from the results was that the majority of the students focused on the sadness of the creature. And essentially, we concluded that they were really using it as an allegory of discrimination. And we ended up submitting it to one journal for publication. And we got some positive reviews, and the editor said, we need you to do some more revisions, which we did. Then it came back again and said, we need you to do some more revisions. So at that point, we ended up submitting it to another journal. And this was published in the Chemical Educator last year. And I'm really proud of it because this is an opportunity to, again, work across disciplines. But the Avengers and Marvel Studios' Black Panther, those are not the only films that you can focus on. A few years ago, I absolutely loved the movie Hidden Figures. I really resonated with the characters, and I loved it so much, I decided that I wanted to create a middle school summer camp with that theme. And that's exactly what we did with a group of students from a local Detroit public school. So we had 12 students, 3 teachers, and we also had 3 parents that also participated as well. So these students participated in a number of workshops, engineering, English, science, and mathematics. And with mathematics, they were learning the fundamentals of algebra. In the English class, the students, the English workshop, the students each were given a young reader's edition of the movie Hidden Figures, of the book Hidden Figures. And they had to work in teams to create a final art project, and they received certificates of completion. So it was a lot of fun. The point is that you have to point out how STEM really impacts your daily experiences to these young people to get them to see that it's valuable. So you can also do something very similar with the Star Wars films. I'm a super fan of basically the original 3 Star Wars. So Star Wars, The Empire Strikes Back, and Return of the Jedi. The late Carrie Fisher was just absolutely awesome as a princess. And also, of course, I love Billy D. Williams for obvious reasons. But the thing is, again, these are just one, you can utilize these films to engage. So one of the things that we've done recently is actually collaborate with students here at Lawrence Tech to develop documentaries, a documentary. And so basically the student that worked with us, her name is Marie Ann Torres Lopez. So she was a media communications major here at Lawrence Tech, awesome young woman. And she was hired by the STEM Center to actually write articles about, or press releases about the activities to publish on our website. So I suggested to her as a senior project, if she could utilize some of my published articles to create a documentary, and she did. So this documentary, Women Untold, is actually on YouTube. So if you go to YouTube and type in Women Untold, you'll get the link. It's 30 minutes long, and it celebrates Dr. Dr. Evelyn Boyd Granville at the top. She's still alive, she's a mathematician, and she actually carried out calculations for 3 NASA space missions. So she's a hidden figure as well. You have Alice Augusta Ball at the top, who actually at a very young age developed the first viable treatment for leprosy. And during her time, leprosy was a serious public health epidemic. And so she actually came up with the first viable treatment. And you can think of it, like in today's, what we're dealing with now, trying to find a viable treatment for the coronavirus. If one thing that we all have seen is that the coronavirus, this pandemic, is showing how STEM and chemistry is really, really matters, right? In this particular moment. And then the bottom photo is actually Dr. Jill Plummer Cobb, who was a biologist, cancer researcher, and she actually became president of California State University, Fullerton. So very proud of this film. We're using it as an educational tool to address equity in the classroom. And finally, I want to just say a couple of comments about the late, awesome Chadwick Boseman. Because like many of you, I was absolutely heartbroken when he passed away at 43 from colon cancer. And so I was heartbroken because he was so young, but also because the film Black Panther made such a huge impact on me personally and professionally. And that same day, when we found out that he had passed away, myself and several other inorganic chemistry faculty member, we received an email from the editor for a forthcoming ACS Symposium book series entitled Advances in Teaching Inorganic Chemistry, Volume 1 and 2. And so it's going to be, so we got the table of contents. This is going to be an amazing 2-volume set. And my chapter is entitled Inorganic Chemistry, Vibranium, and Marvel Studios' Black Panther. So I requested to the editor to allow me to dedicate this book chapter to Chadwick Boseman's memory, and they have done that. And so it's going to be out very soon. I'm really, really proud of it. And it gives a summary of kind of how we have used this movie to engage the community. The thing is, this movie inspired me to be a better chemist and educator, but Chadwick Boseman inspired me to be a better human being. And so with that, basically, what I hope you take from this, this presentation is that I really believe that inclusion of science fiction and pop culture is really valuable, right, for STEM education and chemical education. And not just Marvel Studios' Black Panther, but you can take any movie, any science fiction type film, and make these connections across disciplines, right, humanities and STEM. And diversity, equity, and inclusion efforts is not just the right thing to do, it's good for business. And that's one of the things that I try to do, addressing equity. And the research is clear. You know, you have diverse research teams, that increases innovation and creativity, which is very good for business. And with that, I will close and answer any questions that you have at this time. Thank you so much.
Thank you. Okay, so we want to thank our speaker, and I've seen a number of different questions popping up now. I will actually, instead of me just reading every question here, for persons who want to actually ask the question themselves, I'll open it up for that. You could unmute yourself, and if you wish to ask your question yourself, you can go ahead and do that. And if that isn't working, of course, I'll ask questions that have been posted. Anyone? Aaron, you had a good question. You want to ask that question?
Yes, I can do that.
Hello, Aaron.
Hello. You've mentioned in the presentation about some other working with other disciplines, but have you worked maybe with say physicists to take similar approaches to this education? Because a lot of these science fiction movies rely on physics, quantum physics, you know, and on chemistry as well, but it seems very physics driven. Have you worked with them at all?
That's a great question, and and you're absolutely right. A lot of the physics concepts are touched on in these films. And actually, I'm working on one particular project where I have reached out to a physicist in the department to kind of help me think more clearly, you know, about the concepts. And in fact, I was inspired to do that because there was a book published several years ago called The Physics of Superheroes. And and you might be aware of the book. It's a brilliant book and really helping me to think about, you know, better ways to engage across, you know, across disciplines. So absolutely, I am currently engaging with the, you know, physics faculty on some of these concepts. Great question.
Okay. Another question that seems really interesting is from Daniel. Daniel, do you want to ask it yourself or you want me to?
Sure. So I'm not too familiar with pop culture, but I imagine that Black Panther isn't the only one with, you know, a new fictional element. So I was wondering if there's like any other movies maybe in the past that you've been looking into for other potential topics to look into. I was curious on that.
Yeah, no, that's a great question. And so in the book chapter that I have coming out, actually in the literature, in the introduction, I do mention some other elements. For example, Star Trek at one point mentioned the fictional element dilithium, you know, so there are, you're right, other, other examples that you can certainly utilize. Great question.
Anybody else wants to ask their question directly? Okay. While you guys are thinking about it, let's see. There's a question from Lizzie Borton. This is more on the science education part, I think. Have you seen others or more schools and teachers use this method of engaging students in response to your publications?
Say that question again, Dr. Murray.
Have you seen others, including schools and teachers, use this method, pop culture, to engage students in response to your publications?
Yeah, actually, I have. I mean, in terms of, working with, doing some professional development with K-12 teachers and actually going into their classrooms and delivering these kinds of workshops. But one of the things that we really try to do when we work with teachers is coming from the perspective, asking them how we can help them in the classroom. I think too oftentimes people on the outside looking in that don't know what it's like to be a K-12 teacher, they don't have, they think that they know how to solve the issues. We come in with the perspective of asking teachers what works well and how can we better support them in the classroom. So that's one of our key approaches. But yeah, so we have, received emails from folks, teachers saying that they're going to utilize it in the classroom. I've received a couple of emails from chemistry faculty members that have read it and incorporated it into their classrooms as well.
Mm-hmm. Okay.
Hi, good evening. My name is Anaya. I'm actually in Trinidad right now, and I'm really excited to share this with other persons I know who are interested in, science education. But I was wondering, you mentioned, studying this fictional element and the properties about it. Do you think that there's any potential for the properties that you find here to be applied to current science research and actually bring about some results that we didn't even know were possible just off of these fictional elements and other stuff like that?
That's a really great question, and I'm jealous that you're in Trinidad. right now. But yeah, so there was, it is a way to really look at elements and materials that currently exist, and talking about future technologies. There was an article that I read shortly after the movie Black Panther came out, was released, looking at real technologies, that kind of that are related to what was discussed in the movie. So absolutely, I do think it's that's the whole point, right? Is using this fictional element really just as a hook to talk about real science and real applications.
So, Isabella, you have a really good question too.
I can read my question.
Yes.
Okay, so my question was, do you think that movies with enough influence could negatively affect by fooling or misleading viewers subconsciously to believe in pseudoscience if scientists don't bring it into conversation?
I personally, well, there's a negative effect to, a lot of stuff. I actually think this is, using these fictional elements or science concepts is a really cool marketing tool for what scientists are really doing, you know, in the classrooms and in the laboratories. But I do think it's important that scientists like us, you know, do challenge what's actually, you know, in the movies and pointing out real concepts, you know, and real applications. So that's an awesome question.
Yeah, part of the reason why I thought she should ask that question is that we live in an age right now where there's a lot of conspiracies and pseudoscience out there.
Yeah.
And so I think greater engagement of scientists and stuff with the culture and with different, you know, things of that sort would be of benefit.
Yeah,
yeah.
Absolutely. And, you know, the thing is, because really, Isabella's question, I think, is getting to the importance of scientists being effective science communicators, right?
Exactly.
And we often spend a lot of time presenting ideas to people that have backgrounds in science, right? We don't necessarily, we don't really get the training to, you know, deliver TED Talks, right, to non-science audiences on what we do. So yeah, the point, you know, I think her point, Isabella's point, is really about the importance of scientists and chemists and physicists being much better science communicators, and really talking about the relevance of our work and why it matters, you know, to the community.
Mm-hmm. Okay. Anyone else? We have, I would say, about 4 or 5 more minutes of questions and answers. So anyone else would like to actually directly ask their question to our speaker? Andrew Wee has a really interesting question too about your future plans. Andrew, you want to ask that question?
Yeah. So, hi. Are there any other research projects you are currently working on in order to relate humanities to STEM?
Yeah, I am working on 2 projects. One project I'm working on, so I've been invited to serve as an editor for a new ACS symposium book focusing on the contributions of African American chemists. Basically, again, it's a way to address equity in the classroom, but my vision as an editor, this is not a chemistry textbook. We're combining both chemistry and history, right? And history of chemistry. But what we really want to do is have, for example, real lesson plans that educators can use and write in their classrooms. And it's really about storytelling, right? So storytelling and chemical education. So that's one project that I'm currently working on. I'm excited about it. This is the first time that I have actually served as an editor of a book. So keep me in your prayers as I do this. So yeah, so that's one particular project I'm really, really excited about.
Okay. All right. Anybody else would like to ask a question? Any of the faculty has something that they would like to ask? So mine is more of a comment rather than a question. It might have a question, I don't know. But anyway, I think it's pretty commonplace to see science in the movies, right? I mean, it's a long tradition of many franchises and stuff. So that's not unusual. But what you are engaged in is sort of like the reverse of that, in a way, like taking the movies as the starting point, the point of departure to teach science. Do you, and there, in fact, you know, when I was going to school, I went to school at Wayne State too for my graduate work. There was at least a couple of professors there that very much engaged in popular type, you know, analogies and used literature and all of that to connect to chemistry. So there is some tradition into which what you're doing falls. Do you have any sort of like prognosis or like predictions, maybe would be the better word, of how this could become an important part of science education?
Yeah, no, that's a great question. And one of the things that I have been trying to do with my own teaching when I was a faculty member and even now is trying to get faculty to just teach a different way, you know, because honestly, years ago, you know, when I was first started out teaching, you teach the way you were taught because you just always have done it that way. And actually, I had an aha moment about 10 years ago when I was teaching at the College of Wooster. And at the time, I was teaching second semester general chemistry, focusing on electrochemistry and batteries, right? And you know, that's not an easy topic to teach, balance of redox reactions. I love to do that, but that's you know, that's a challenge to teach and for students sometimes to grasp those concepts. But as I was preparing my lecture notes, the book that I was using had a picture of an iPod in there, or MP3 player. Now we know that iPods are vintage, you know, devices now. No one uses an iPod. Well, I still use mine to listen to music. But I decided, okay, this is how I'm going to go and teach this concept. So I go into the classroom and I told the students, the title of this lecture is "What's in Your iPod?" Tell me who's in your playlist, right? And they were so engaged, naming all of these artists I had never heard of. And they laughed when I told them I listened to Beyonce and sometimes Snoop Doggy Dogg, and they were really engaged. And I said to them, okay, now we talked about your playlist. How does this iPod work? It's got a battery, right? And so then we started reviewing common oxidation states for elements on the periodic table and started balancing redox reactions under basic and acidic conditions. But they were so engaged and really into it, I decided to prepare a manuscript for the Journal of Chemical Education. And it was accepted, you know, and that's when I was like, okay, this is how I could, you know, I'm gonna try to change things a little bit, not just go in and say, solve this equation, you know, balance this redox reaction. There's no fun in that, you know, as far as the students are concerned. So I just try to come up with ways to do that. So I've been doing this for over 10 years, you know, really trying to find ways to engage young people. We published a paper focused on using hip hop and rap, you know, to engage students with the periodic table 8 years ago. You know, so I'm just trying to do what I can to encourage faculty, just try something a different way. You're not changing the content, you're just changing how you're presenting it. You know? So I'm hopeful that we'll see more faculty embracing that approach.
Yeah, I kind of describe it as teaching in context to the real world. And one of a simple exercise that I gave my grade 10 students is similar to what you did, which is to find for me all of the elements that are found in their smartphone. You know, and these are grade 10, so they need to get the symbol, the atomic number, and even things like where those because a lot of them are really expensive transition
Right.
metals.
Mhm.
Where are they located in the world and stuff? So it becomes an interesting exercise. They learn the elements, you know, and they have it now in the context of something they use all the time, their smartphone.
Right.
Yeah.
That's awesome.
Yeah. So anyway, is there one last question? If not, we can wrap up. Anyone?
Well, I just wanted to thank everyone
Okay.
for joining me in this conversation. This was so much fun. And hopefully when this pandemic is over, I can actually step foot on the campus
Okay.
of Andrew University. So I would definitely love to visit at some point. And you guys have a wonderful fall semester. Thank you so much.
You're welcome. We appreciate you accepting our invitation. And on behalf of the faculty, the staff, the students, both majors, minors, and everyone else who is looking in, want to thank you for a very interesting and stimulating presentation. And
Thank you so much.
you and I will be in touch.
All right, take care.
Okay, take care.
Bye-bye.
Bye.
Bye-bye. Thank you.
Bye-bye. Bye-bye.